the following sessions we're going to talk about running the MTF test in the CTE and in general. In order to run MTF, one basic variable we need is called IFOV. IFOV is directly connected to the resolution that we can sample with MTF, or the maximum resolution, or what we would call Nyquist frequency. So we need to know this value in order to be able to plot the MTF. So in the CTE we have a test called MTF calibration, and by means of projecting either a 4-bar or a square target, we can calculate this value, or if the customer or the operator knows this value and wants to use his own value, he can enter that in what we call the global variables list for the part number and modify it per his needs. So in here, what we would do, in order to run the MTF is also based on not only on the imager, but also on the optics. So we have here all kinds of MTF tests. Basically, they're copies of the same test, but just configured differently. We're going to run the MTF test, first of all, MTF calibration, and then MTF all right, and then the MTF test. So the nomenclature that I use is, I would call MTF calibration narrow field of view, and we're using the visible camera. You can of course rename these as you wish, but when I send out a system, I try and keep a generic nomenclature. You can then change it as you wish. And since we have a source here in this column and an integrating sphere, I ended up with an IS as a suffix to the name of the test. So this is the MTF calibration. This will run and calculate the IFOV. And then after we complete the IFOV, the output of this test will be the IFOV values, both in the vertical and the horizontal direction. And then we'll be able to run the MTF either vertically or horizontally, depending we have a vertical or horizontal step target. We usually run the MTF on a step target. Now we'll go into the setup of each test and how we define and then run the test. Thank you. Now we're going to run the MTF calibration setup, which is the first thing we need before we can run MTF. Just as a word, general note, for every camera that we run MTF for a different field of view, the calibration should be done usually at least one time, but it can be done every time prior to running MTF, because basically the IFOV doesn't change in the camera. We just need to know what it is. So if you run the MTF calibration, you can go straight right ahead to run the MTF, unless you have a reason to run it every time. Anyways, so we have here in the execution panel two tests, the calibration and MTF test. Now this is for the narrow field of view. The reason I'll go into details that these are linked together, where everything that has narrow field of view on it. So some of the parameters, the output parameters, are linked to the input parameters of the MTF test. So it's easy to follow. So if we want to run the medium field of view, we would run the medium field of view MTF calibration test with a medium field of view MTF test, and so on and so forth. Now, field of view is a generic name. Medium, there could be wide field of view, super wide, or super narrow, whatever, as long as you just keep the nomenclature. So in order to go to setup, we need to double click on the test, and we have here the setup panel. So once we've opened up the test panel, there are a lot of variables that you can change and modify, and I won't go into what type of variables you have here. You have input and output variables. This will go over in another presentation, because it's basically the same in all the tests. You have input variables, you have global variables, you have local variables, and we need to be able to set them up properly. In the MTF calibration, we have 4 output results that are calculated with the test. 2 are IFO X, IFO Y, and the equivalent is a maximum frequency X, maximum frequency Y. IFO X and IFO Y are outputted to some sort of global variable that we call FOV, IFOV, blah blah blah, and these 2 variables, the IFO result will be afterwards input as a variable to the MTF. So that's why you have to run the calibration first. The maximum frequency is basically the highest frequency that the camera is able to resolve theoretically, and it's equivalent to what we call the Nyquist frequency, and we use that when we plot the graph of the MTF. We also need, since this MTF is being run on a visible camera, we need to set up the parameters for the visible light source. So we have, in our case, in our test bench, we have an integrating sphere, so we need to know what is the calibration table. It's already set up. Most of these parameters, by the way, are set up prior to delivery to the customer. Someone at CI, test engineer, test applications engineer, performs this for you. But what you can set up and what needs to be changed is usually the intensity of the integrating sphere. In this case, we have it set to 5 foot Lamberts. And we have to see the sensitivity of the camera. It may need more, it may need not. You want a good contrast when you see the image that's projected. We need to set the source stage, okay? Because not all systems have a source stage, but in this case we have a source stage. So if you have a source stage, you need to set it up. Again, it's set up for you, and we select the integrating sphere as the source that will be positioned behind the target wheel, or the target in the target wheel. Then we need to select the target. So the target for MTF calibration has to be some sort of geometric target that we know its geometry, or it's easy to calculate its geometry. We use either a square target or a 4-bar target, because both of them are, their perimeter are square. 4-bar target, the way you manufacture a 4-bar target is that it's 7 times the bar width on let's say vertical side, and the horizontal side is at exactly 7 bar width. So you get a square target in the perimeter. And then if we know the 4-bar target frequency, we can convert that to the bar width and the bar height, and excuse me, the side and both sides, the height and the width of the square or the 4-bar. And from this we can calculate the IFO. The IFO is basically the size, the spatial size in let's say the square. Let's say it's 1 milliradian, and if it takes 100 pixels to cover those that 1 milliradian, the IFO is 1 milliradian over 100, 1/100th of a milliradian in size. And the IFO is basically the spatial field of view of 1 pixel. Okay. Then we need to determine what kind of imager we're using. In this case, it's an analog camera. Again, I'll explain how we select the camera. We need to determine the number of frames to average, This is a parameter, usually 25 is enough. It depends on how noisy the image is. The more frames you average, you kinds of reduces the noise when you make a measurement. And we need to find the exact perimeter of the target. Finally, you have what we call the region of interest, vision ROI. And this, when we run the test, we will need to prompt or position our overlay around the projected target, because there may be a lot of other objects in the image, and since we can't determine that ahead of time, we want to point the software in the area where we want to make the measurement. Let me put a pause. Okay, so let's, just for an example, if we want to change the value, we just need to double click on the edit box, and we can change the value, enter 6 or whatever, let's say for the intensity. And if we want to change, let's say, the number of frames to average, you can go to 30, etc., etc. And that's about it for this. There's one more, yes, okay, there's one more variable that I'll show you. It's called manual or automatic. It's a flag. This can be changed or selected either manual or automatically. This will determine whether you manually determine the perimeter of the projected target, or you have the software do that. Sometimes the system is so noisy and our algorithm just can't determine the outline of the target. So we go to manual mode. So the default should be automatic, and we'll demonstrate that later. Thank you. I just want to add one more thing on the MTF calibration. We can, almost any output parameter, we can set pass-fail criteria. So if we have the iPhone here, and you want to measure it, and you want it to be within a certain tolerance, you can right-click on it, on the output, and you see you have a menu here, and it says edit criteria. So I could set it up anywhere from, say, 25, or let's say, excuse me, let's go to 50, to 100. Oh, I did too much, excuse me. 25 to 100 microradians. I click OK, and you see the criteria is displayed over here. And as long as the value of the result is in this range, I'll give you a pass. So if this is important to you, almost any parameter that is outputted as a result or is calculated, you can set this criteria. Finally, after we finish setting up all our parameters, we need to save, of course, the system or the test file. And we click on the Save button and then close it, and we're finished setting up the system. And now, once we've set up MTF calibration for, let's say, for the narrow field of view visible camera, we're going to run the MTF calibration. As I said before, this is the test executive execution list. Basically what it would do is that if there was more than one test listed here, it would run sequentially one after the other. But since we're doing a training, usually I run one at a time. I select one test and run it, and I select another test and run it. And it's easier for me, but it may not necessarily be the best way for you. You may be running an ATP. So we position our mouse on the test we want to run, click the Start Execution button. Make sure the setup mode is on, okay? This can be toggled on or off. It should be on. That means that during the test run, the region of interest which is one of the parameters of the MTF calibration, will be prompted to the user. Otherwise, it will use what was internally set in the test setup. Click the Start Execution button, and we see it opens up the vision window, and there's a panel that's displaying the current intensity of the integrating sphere. It's displaying the current target that we selected, and it's displaying the current source that we selected. So we selected the vision source, or the integrating sphere source. And finally, once it reaches its position and everything is set up, the user is prompted. And here it's prompting you with some message saying, select a region of interest that's slightly larger than the projected target. And here we have the target. This is the SWIR target. And so we need to select. And we see here, you can see here, the limits of the collimator field of view. So of course, anything beyond the limit of the collimator's field of view is not within the optical calibration of the system. So you should make sure you never take a region of interest or make a measurement outside of that field of view. And click OK. It's now acquiring or doing its measurement. We need to wait. It takes a few minutes. And once it finishes, it goes to the next stage. It starts analyzing the data it's captured, and then it projects finished or test completed, some sort of message. And what we see here is the perimeter of the projected target. It means it was able to determine the size of the image, of the projected image. And here we have the results. So here we see the IFOV in microradians comes out to 115 microradians, point something. And here on the vertical it's 113, so almost squared, maybe off one IFOV. And here we have the maximum frequency is 4.3 cycles per milliradian and 4.4 in the Y direction. Click OK, and the test complete. Okay. So once we've completed running the MTF or any of the tests, we come to report generation, and we see down here. Remember, this is where we have the report summary and where we could generate reports. Report summary is different from report generation, whereas the report summary we can only see the summary of the tests, including the test parameters, but they can't be printed and put in a report. So if we double click on this, we see, let's minimize this for a second. We see the test results that we had from the test. Red signifies failure, and obviously IFOV X failed our criteria. We had it set up for 115, between 50 and 100, and the value was 115 microradians. IFOV Y was just measured, so it's green. Anything that didn't need to pass the criteria is always green, and if it was within some sort of pass-fail criteria, of course it would be green. In the next tab, we have the calibration parameters. These are the settings in the test. So we keep a record of that. So each test has its record of how we ran the test for future archiving and comparison in the database. And then we have another tab, summary. If we want, we can add a remark and say, this is training. or whatever, and it will appear on the report. We can also select a tag if you want to link a few, like a hashtag. We want to link a few tests to some sort of event. And then, so that's basically what we can do here. We can close it, and we go back to the test results. Now we can generate a report. So there are many ways to generate a report. The easiest and the most common way is to use the quick basket. We click on the report that we want. If there are a list of reports or a list of test results, we can create one report. And we click on the create report, use the quick basket, you see, and it opens up another window where you can fine-tune the report settings. If you want the test header to include the operator and the sequence and the configuration. So this is basically useful when we're running ATPs for in-house or factory uses. Anyways, we click on Create Report. We can also add a note if you want. And this is a general note to report as opposed to the test report remark. So this is, if I put here a note, I can say this is a general report. Create report. And we have an HTML file that is displayed with the report heading. It displays the report part number, serial number, the test name, or tests list, the summary, and here we see a general. Here we see the general report, and then we see the results, the failure of the IFO, and there was another remark, and this is the test remark that we entered. This is training. Thank you. Now we're going to run MTF tests. So we need to select the MTF from the test list. Before we did the MTF VIS with the narrow field of view, so we're going to test the MTF narrow field of view VIS with the integrating sphere, because that's our source. So now this is in the test execution panel. We double click on it. We open up the test parameters list. I'm just going to minimize background so we can see it better. Here we have input. MTF calibration X and Y is basically the IFO results from the MTF calibration that we did before. And we're going to use this to be able to plot the MTF on the system. And we need to select the radiation source. So it's already been selected because these tests are pre-set up at factory, and you're using the visible sphere or integrating sphere. The radiation target also is usually set up. You usually take step target. Step target has the best optical characteristics in the system. But if there's no step target, you can use probably a square target to run MTF2. Now we have two variables here. One is the result, tested frequency at the specified frequency values. So we need to set up a vector called tested frequency. In this case, we have 6 variables. We double click on it and we can set the frequency values that we want. We can change the size if we want to change the size. Let's say we only need to go to 2.5 cycles per milliradian. So we could change, we only want 5. So we change the size of the vector to 5 and it deletes 1. Or we can do it the other way around, increase the vector size, and we can basically set the vector size as large or as small as we want. But once you change the size, tested frequency size has to be the same as the output frequency vector size. So we need to also change this variable. So we right click on it, click edit size, and we go from 6 to 5, click on the OK button. And now what we can also do is change the criteria that we have in the system. So basically, MTF is a normalized graph from 1 max to 0. At a frequency 0, the maximum value should be 1. That is in most cases. There are exceptions where sometimes the frequency or the value of MTF is greater than 1 at different frequencies due to some sort of maybe frequency boost in the system. And anyways, we set the pass-fail criteria, making sure that the values that, or assuming that the tolerance value is less than the expected MTF value, so that the MTF has to be greater than these values. The frame grabber, or the imager that we're using here, is the analog frame grabber. It too is set up through a global variable, and I'll explain global variables in a separate presentation. We have the number of variables, number of frames to average. Here we start with 25. It's a good beginning value. The higher the number of frames we average, basically is used to reduce the noise in the system. When you run an MTF, you need to have a good contrast, and so you want to reduce the noise. That increases the contrast to run the MTF. Okay. And finally, we need to set the region of interest. That we usually do that in the test, though it can be done in the setup. One more thing that we need to know is setting the output intensity. The output intensity should be just enough so that the system does not go into saturation. Again, the higher the intensity or the radiation intensity, the better it is for the measurement. You get a better contrast, less noise. But you have to remember you cannot go into saturation. If you go into saturation, the MTF measurement will not be valid. And a way to estimate the saturation level would be to use the line profile and increase the intensity, see where the signal is starting to saturate. And I can show that later. So let's say we need to go to, let's keep it at 3 foot lamberts, make sure that we're not in saturation. Click the OK button and exit. Thank you. So now, after we've set up the test variables for the MTF test or visible test, we need to run it. So we select the test we want to run, highlight the test, and click on the execute button. And we see that the integrating sphere is turning on. We see the step target that was selected for the test. It's setting up 3 foot lamberts. And the radiation source, of course, is the integrating sphere. And here we see just the device center is, of course, the same as in the test panel. Now we need to select a region of interest because it's prompting us. As I said before, this can be either set inside in the test setup or during when running the test. I usually prefer to keep it set to run during the test because it's easier to set up, but sometimes in the production line it has to be fixed. So there are ways to fix it. And we follow the prompts. It says select the ROI. It includes the step edge, so it's between the background and the step, the projected target. Remember, you see here basically the boundary of the field of view of the collimator. This is the target, the full target size. Anything beyond this target size here is basically invalid optically. It's not in focus. Thermally, it's not same temperature if we're using an IR source. So just make sure that whenever you're using a region of interest, or whenever you're and it prompts you for a background, it should be within the field of view of the collimator. Okay, once we've set the region of interest, you of course can increase, decrease the size, and you can experiment to see how that impacts on your MTF measurement. You can't make it too small. The smaller you make, the less, the more coarse it is, and the algorithm can't basically make the measurement. So you need about at least 32 pixels wide before you can get a good MTF. Click OK, test is running. We wait a few minutes or moments. Okay, we stop the countdown by clicking on anywhere within the panel of the MTF test. It stops the panel, otherwise it'll close it automatically after, I think, 9 or 10 seconds. And what we see here is a summary of the test. We see the measurement, frequency measurements at the points that we set up in the test setup. And actually they passed every point. And we can see then here they're plotted on the graph. And you see that the MTF is greater than these plotted points. Okay, this was by choice. And last but not least, we see the MTF. We can see the edge spread function, which is basically the line spread here, the average line spread of all the frames that we captured. We can see the line spread function, which is the derivative of the edge spread function. And then we can see the CTF, which is a calculation based on the MTF values. There are some systems that require the CTF calculation because they only have square targets. They use a square target, not a square, but like a 4-bar contrast targets to make the measurement, and it's a derivative of MTF. Finally, we complete the test, and the test does its post-processing. So it's just turning off the light source. So we want to save the light source, the lamp. We want to increase the lamp longevity. So we always try and turn off the lamp when we complete a test. Thank you. Okay, finally, after running the MTF test, we want to see the test summary, and then if we need, we can generate a test report. So the test summary is listed here. We see the summary, when it was run. See there's a green checkbox, meaning everything passed. We can double click on it. We see the measurements that we did, the vector measurements of the tested frequencies, the value, the criteria, and whether it passed or failed. It's all green. We can see again the plots of the graph, CTF, the edge spread function, the line spread function, finally the MTF. And we can also use, we can export each plot. They're comma separated. Click on this button, go to the export function, and it generates the file. And this can be exported to an Excel file or imported to an Excel file. And you can do your further calculations between different UTs or whatnot, whatever you want to review. Now we want to see a report. So again, we select the quick basket, and you can click here on the create report. Use the quick basket. Basically, I want small images, otherwise it'll take too much space. Small. If you want to add a note, you can add a note. create the report. And here we have an HTML report, which includes the report, part number, serial number, test name, whether it was passed, summary, whether it was passed or failed, the results, the measurement results, and the graphs that you have. This can, of course, be either printed to a printer if you have a printer, or saved to a PDF file. This is all already part of Windows. That's it.